This is a graphing application that allows you to produce some high-quality plots of 3D and 4D functions. There are two main aspects to producing these graphs. One is the equation editing interface, and the other is the workspace viewer. First, let's investigate the equation editor. This is an empty graph at the moment, and we're going to quickly make it rather more interesting. To do so, let's open up the editing interface by clicking on the origin and constructing a simple function. One of the ones I like to demonstrate with, because it's simple yet very pleasant to look at, is the product of sine x times cosine z. So to construct that, we're going to pull out a value block. These represent one of the variables or a number, and a multiplication for the sine times cosine product. Then we pull out a sine and fit the x into that block, and a cosine, and grab out a new value block, and let's put z into the cosine. Then we multiply them together with the multiplication block, and let's see how that looks. That's pretty snazzy, but we can make it even nicer by simply using one of the extra options over here by coloring the graph based on the slope of the graph at a given point. Here you can see that in action. We've got a slope coloring key above the graph, marking where the slope is a given value. That means at the top of these hills, the slope is 0, which corresponds to the 0 mark on that color graph. And where the graph is that nice sea green color, the slope is about 1. Now you've probably already noticed that we are viewing the equation. This is the workspace viewer that I was talking about earlier. I'm moving the camera around with simple WASD keys and going up and down with Control and space. There are a couple other keybinds that allow you to move faster or slower, and this provides you with a lot of freedom in interacting with the 3D environment. This is particularly fun with more complicated graphs that have more three-dimensional spaces to explore. Before we get to that though, I'm just going to mention that the color of these graphs can be customized with these values here, and indeed you can choose a random color, which turned out a little bit dark here, but that's because it's translucent, and translucency is something that my rendering engine fully supports. The whole program is written using the lightweight Java gaming library, and in particular, the rendering engine uses OpenGL. This includes the full range of graphical interface components that one would expect from an application. The nice thing about the format of these workspaces is that you can have multiple graphs in the same region. So let's move on to something a little bit more complicated now, but we're still in the same workspace, so it's easy to start something new. A really cool part about this application is that there are so many different coordinate systems that you can choose from for graphing. I'm not going to go into something too weird here though. I'm going to stick to the spherical coordinate system, and let's start with a simple sphere of radius 1. Ooh, that's a little bit strange with the textures, isn't it? Luckily, I do have a default domain button that makes that much nicer. There's a default domain available for every coordinate system, which means that even in coordinate systems you are unfamiliar with, you can get a fairly good looking graph quite quickly. To complicate this a little bit further, let's have the radius dependent on one of the other variables in the spherical coordinate system, say phi. Phi is one of the angles, and you can see what the different variables in your coordinate system are by looking at the domain fields over here. You can see spherical has a phi domain and a theta domain. So we're going to have radius equal to phi, and let's see how that looks. That's much more interesting than the other one, isn't it? And as I was saying earlier, one of the particularly fun things about this application is that you can fly around inside the graphs that you're looking at. Unfortunately, discussing the full range of features of this application goes well beyond the length and scope of this video, but I will try and show you a couple interesting demonstrations of some problems and solutions that I found while writing it. Obviously, one of the main concerns with drawing a surface is connecting a couple points together, but equally important is knowing when not to connect the points. This graph demonstrates that quite well, I think. My program uses a combination of slope, tile size, and upper and lower range to determine whether or not two points should be connected. Another key feature of the visual equation block system is that you can define a function in one location and then reuse it in others. Here I've declared a variable parametric function in one area, and over here I'm using that same function and tweaking its values just a little to create two grids of graphs to illustrate how that function reacts to changes in its variables. Here is a cylindrical graph that oscillates with radius and ascends with theta. The amplitude and rate of ascent increase with increasing values of theta, and scaling is large enough to provide thoroughly enjoyable exploration. The slope is displayed as color and changes more vibrantly as you go up because of the increasing second derivative of the function. My equation blocks have a number of advanced operations, including various numerical calculus operators. This workspace is a test of those operators' precision, and although the details are unimportant, the result is very interesting. One of these two plots here is the graph of the volume of a sphere with radius x, as determined by the formula 4/3 pi r cubed. The other graph determines the same thing, but does so with 4 layers of numerical calculus operators. Despite that, you can see that the two graphs coincide perfectly, which shows that the calculus operators are indeed very accurate. This is a triple wave interference pattern, with varying amplitude, frequency, and location, along with the flattened version of the graph, which increases visibility of certain parts. These graphs were put together for the express purpose of being visually appealing. I've designed them to thematically match a few different songs that I've done guitar covers of. The graphs reflect in the glossy finish on the guitar, which I think adds a nice effect. Thank you for taking the time to watch this demonstration video.